Yeah, good afternoon, everyone. Good afternoon, everyone. Myself, I'm Janki from Pantech Solutions, Hyderabad. So we provide the minor and major projects, and we support your creative ideas, and we also conduct the webinars and workshops. So very thankful for the Adhiparasakthi College of Engineering for giving this opportunity to conduct the workshop on IoT application for weather predictions. So I hope everyone joined, right? Okay. So today we can learn some basic knowledge of IoT and its applications, where we use it, what are the types of IoTs and all this. So what is Internet of Things? Yeah. So everyone, my voice is audible? Yeah, please. So I can go further. Hello. So, what is internet? What is IoT? So, Internet of Things is nothing but some cloud computing system. So, there is a communication between the two devices. There is a communication between the two devices without the help of the humans. So, we exchange the data and we receive the data without the help of the humans. So, this is the internet revolution. So, how the internet was developed by year. Like in 1969 to 1995, there is the internet of boffins, and in 1995 2000 there is the internet of geeks. So these are the some communication developments. How was internet developed by year. So internet of masses like 2G, 3G, 4G. We have some devices, mobile networks in 2007 to 2011. So internet of things was developed in 2012, and beyond till now we are using this IoT. So how we use this IoT? Like for example, we have our WhatsApp. For example, can take some example, right? In mobile WhatsApp, we use a WhatsApp. So we send a message to one person, and it is received by the other person. The other person has not seen the message, so the message is stored in some cloud. So this is a IoT. We use IoT in different purposes, so machine learning, AI, all this use. Okay. So why internet? So what are the applications of internet? So we can use it anytime. At any time we can use it anywhere for any person. There is no rules and regulations to use the internet. So for any person, for any business purpose, we can access to any device and any network. So 24 hours it is available for us to use the internet. So first, how the internet was developed. So normally no one owns the internet. It's everyone's source. So there is no any formal management organization for it. So firstly, it was developed by some department for defense. In some military purposes, we use this defense services. We developed this internet. So there is a lack of centralization. So at that wartime or terrorist attacks, it is very less vulnerable at that time. So how we access the internet is, we have an existing network. We have to have an existing network. We need to pay some registration fees for that network. So we will get some certain standard based TCP and ICP protocols. We have to agree to that, and we after paying some registration fees we can access to the internet. So history of internet was developed by Kevin Haston in 1999. So in simple terms, how can we say what is Internet of Things? What is IoT? So IoT is nothing but describes the physical objects, the connection with the sensors, some exchanging of the data between the two devices. So Internet of Things is nothing but a networking system of physical objects and devices, vehicles, buildings, software and other items which are related to embedded systems. So the connection between the network of objects between the embedded systems, it's exchanging and collecting the data from the software, sensors, all this network connectivity that enables us to collect and exchange the data is called IoT. So in a single sentence you can say anywhere, anything you go, there is a whatever the electronics you choose are all are related to IoT only. So SMA gadgets, where incorporate sectors in screen gathering, install sensors, some remote control purpose, web page based, all this related to an IoT. So RFID media base, all these different purposes we use IoT. So it is in one, you can also refer it as a machine to machine communication, like a Skynet or Internet of Things. So there is a communication between the two devices, two machines, without the help of the human. So how we use this IoT in schools, like smart Internet of Things in school. So we use IBcons are like any Bluetooth like RFID tags. So different we for monitoring the data of the student, the location tracking, so video capturing of the lecturers, for cleaning the rooms, robotic cleaning. And we also have a e-textbooks, online textbook notes, some tablets and smartphones, some cloud-based formats for file storage, all this cloud storage IoT. And also for exam writing, in exam halls we use this, some digital class whiteboards. So Wi-Fi, we control this all by using the Wi-Fi sensors and locks, classroom doors, automatic open and closing. As well using the sensors in parking IoT and driver ways. So monitoring the display of air quality, knowing the air quality in the school environment, how the environment was. So different purposes we use this IoT in small schools. So this is a literature review of the IoT, like how many people were interested to use the IoT. Like 7 out of the 10 people, everyone has a IoT device. So out of 3 out of 4, we are planning to purchase an IoT device in the next 12 months. So compared to this, how many people are interested? Some people are concerned about the personal information being leaked. 81% people were worried about the personal information. And some are very concerned about the hackers, any hacking tools will be there to commit some crimes. So different people have some different issues to find a device IoT. So these are the IoT applications, like where we use the IoT. In different sectors we use IoT, like healthcare, environmental, smart cities, commercial, industries, infrastructures. So healthcare, you can have some healthcare like a smart health monitoring systems. You have idea of smart watches. And in hospitals also use some for how many members are there in a hospital, like hospital monitoring systems, management system. So knowing a pulse, we use smart health, like I can know our own health without going to hospitals by using some sensors like pulse sensor. This is different. We upload the data to the cloud. So environmental purpose. This environmental purpose, you can say smart farming, smart agricultures, wild vegetation, climatic changes. Some environmental purpose, weather condition predicting. Some smart agriculture, like agriculture robots, automatic in irrigation systems, weed removing robots. In environmental purpose we use this. In smart cities, like a smart home automation, automatic bulb on and off according to our mood, our torch, we can control the home. So smart building applications. In traffic monitoring, some security purposes, emergency situations like vehicle collisions. Different in smart cities we use this IoT. In commercial systems, like a shopping system, retail, like Amazon, Flipkart, we different sites we shop, right? So in shopping sites also, like IoT, some cloud data we use to store that. As well we use RFID readers, tags, we track the location of the customer product where it is reached. And all purpose we use this IoT. In industrial purpose, like smart grid and smart metering, like a smart energy meters we use IoT. Okay. So IoT application in healthcare. So how we use it? In healthcare? It is like we use some smart sensors to collect the data. So by using some connection gateway, like any protocol, we upload the data to the cloud. So we control it by our own phone, like remote signal. So we can observe the data the collected data in the whatever the sensor data is stored in a cloud. We can monitor the data within the smart device. From a mobile only we can monitor the data. So IoT applications in smart cities. So how we use this IoT in smart cities, like some sensors, sensor was installed at the parking spots. Already some underground of that parking spot, a sensor will be installed. So all the city, the sensors will pass the occupancy status of each spot to the cloud. So whenever the vehicle passes to the sensor, it will spot the occupancy will be spotted by this cloud, is uploaded to the cloud. So how many number of applications you can consume the data and be stored in a cloud. So it will guide the drivers to the shortest route to an open spot. So for smart parking purpose uses. So IoT applications in industrial automation, like a smart tracking for products in transit. So tracking the delivery wherever product is reached, it notifies the users, like delivery plans uses. Some digital factories, and it also improves the line of commands in working units. So in real-time monitoring how the food supply chain is working. Some cross-channel verifications in inventories uses. In product quality testing, like in manufacturing processes, packaging optimizations, we use smart IoT technology. So the IoT applications in agriculture. So how we use IoT in agriculture, like mainly we collect the data from the sensors. So we sensors and actuators. So what is a sensor? So it sends some input data. Sensors all are the inputs. So we collect some remote commands, and it is given to the connection gateway. So we can display the outputs in you can see that sensor data on display in a mobile or a monitor. So here we use the smartphones. We use some commands to that. Remote control commands means by mobile phone is used as a remote control. We give some remote commands to the gateway. So the sensors and actuators, we can see, we can pass the commands from a mobile to the sensors and actuators. So sensors are nothing but act as input devices. The actuators are the outputs, like servo motors, some relays. All these act as actuators, like controllers and switch gears. So what is embedded system? Yeah, anyone? Suggest. Okay. So generally embedded system is nothing but some combination of software and hardware by using some mechanical components. So what is system? Generally system is nothing but which do some specific task. all the units assembled together to do some specific task. So in embedded system, it consists of a microcontroller board. Like it's an embedded system means it's a combination of software and hardware. So we use some like microcontrollers and memories and power supplies. Some communication ports for transmitting the data to the other devices. So how the software works in embedded system, like the program tells the microcontroller to how to respond in real time to data, to collect the data and from the environment, and to for peripheral sensors and devices, how to collect the data and respond to it. So where we use these embedded systems, like in domestic applications, in household applications like a washing machine, TV, fridge, all these include this embedded systems. This audio visual equipments, in gaming consoles, in medical devices, telecommunication equipments, these cars and vehicles, some motion sensors, capturing of a motion, like movement, like different purposes we use these embedded systems. So this is a structure of some block diagram of the embedded system overview. So we use these embedded systems with some sensors and actuators by adding some hardware peripherals to it, like microcontrollers and processors and memory and CPU to this. This whole is the block diagram of the embedded system. So we collect the data from the sensors and we give to some high hardware unit, like any application specific logic, like analog to digital converters and digital to analog converters. Some hardware unit we give this, and we add some peripheral like CPU and memory to it, and we get an output called as actuators. We see in a DC motor, servo motor, so LEDs, all these act as actuators. So input and output units, sensors and actuators. So generally sensors all are the inputs. So what does the sensors do? A sensor is a device that measures a physical input from its environment. So they collect the information from the physical data, whatever the data is there we give, they will collect it from the physical environment, they sense the input and it will convert into some data, like it will convert into electrical signal. So the electrical signal is given to the microcontroller. So what is actuators? So actuators are nothing but some devices, a form of powers. They convert to a controlling signal into a mechanical motion. So in simple words you can say it will convert the electrical energy into the mechanical energy. So we have some different actuators like linear actuator, rotatory actuator. You can see some examples here like compact actuator, round body actuator, gripper, like these different types of actuators we use. So like what is sensors? Nothing, we have different sensors like temperature sensor. So how we have in temperature sensors we have some non-contact sensors and non-contact sensors. So like example thermometers. Thermometer is also a temperature, so it will measure our body degree. So whenever we contact with the body, physical contact with the body, only we can know the temperature value, our body temperature, by contacting with the thermometers. So without touching our body, without physical contact also we can know the body temperature by using some different sensors like thermistors. We use some thermistors in mobile phones. So they used to know the temperature of the mobiles, like we get a pop-up notification of mobiles by using thermistors. So in that we use some capacitive and resistive filters. So accelerometer is also one type of a sensor. And IR sensors. IR sensors use the IR rays to detect the object. Ultrasonic sensors are also used for detecting the obstacles and any obstacles and any object is for there by using some ultrasonic waves, sound waves. Touch sensors also have capacitive touch and resistive touch, like touch mobiles, all this. color sensors, TCMP one. We also have some color sensors for detecting the colors. Smoke sensors like gas sensors. Whenever any smoke is detected, automatically we get some alarm of the. So there are steps to follow, like how we in embedded systems, like analyzing the data. First, communicating the device using internets. How we communicate with the devices using the internet, and we connecting to the server cloud for the data storage. Then we are sensing and collecting the data from the nature. So from sensors we collect the data from the nature and we upload to the cloud. Fourth one, we analyze the data. Whatever data we we collected, we analyze the data. So these are the levels of the communication: collection, communicate, analyze, and act. So what is microcontroller unit? Like it is a memory. It's one of the controlling unit. It has the instructions. It takes the instructions and it passes to the controller unit. Memory will store store the data, and this controlling unit will pass the instructions. So this is the simple architecture of the microcontroller unit. So why we use this microcontroller units for IoT? So because simplicity, security, and cost. So in most IoT use cases, the MCUs are a very advantage because they not require any operating systems to function. They can easily interface with the external devices. Like microcontrollers will easy to interface like with the sensors and the motors we use. Additionally, the coding required for MCUs is also very less, is very minimal. So very less coding is required to required for the programming in the MCUs, and it is very easy to interface with the sensors and the motors. Security purpose also, like where MCUs offer very less attacks. There is no cyber attacks on the securities. Like they have some open protocols, and it also very potential vulnerability in it. So cost is also very less. It has an abnormal cost, economical cost. It has many applications in IoTs. So in simple words, what is a microcontroller? So it's a full computer system on a single chip. So it's a single chip with a inbuilt module. We cannot change the peripherals in it. It is already inbuilt with some memory and processor. It is already inbuilt one. So these microcontrollers are used for standalone operations. So they are independent operations. So what is the difference between the microcontrollers and microprocessors? So microprocessor is it acts like a CPU. Like we have to add some external peripherals to it, like RAM, ROM, input ports, some timer and serial COM port. Some data bus we have to add. In microcontroller, already all the peripherals were included in it. We cannot change that. Microprocessor is a multitasking, but it cannot own all the functions of computer, because we have to add some external circuits to it to support some input devices, output devices. We have to add to the processors. Okay. So microcontroller adds some timer module to perform some task at a certain time only. At a certain time, it should perform some specific task. So it has a timer module and it has a serial input port. So this controller has an input port to allow the data to flow. Other devices like such as PCs and other microcontrollers you can take. So it has an ADC, analog to digital converter, to allow the microcontroller to accept some inputs of processing. So this is the history of the microcontroller. So in 1971, Gary Boonley was invented this microcontroller. Okay, these are some inventions. So these are the popular microcontrollers. You have chapters on this like 8051, 80386. PIC microchip, 68805 Motorola, Z8 Zilog. These all are the companies of the microcontrollers. So how to choose the proper microcontroller? The criteria for choosing a microcontroller is like, first, how many input ports it supports, number of input ports it has, some serial communication modules like UART protocol. Then communication modules are possible in this microcontroller. We have to see some peripherals like timer, phase, pulse width modulations, ADCs, some memory storage, memory requirements, some processing speed of the hardware, power supply, how much voltage it can support. All this we can check before buying the microcontroller. So microprocessors. Microprocessor is generally multitasking one. It consists of ALU, control unit and register array. So you use this ALU to perform some arithmetic logical operations. We externally add this input device and output device and memory input in unit to this microprocessor. So these are the basic microprocessors like the clock speed, the bandwidth, what the data types we use in it. So what are the instruction sets we give? Node MCU. You already have an idea of Arduinos, Node MCUs, Raspberry Pis. These all are the different controllers we use in the projects. So all the base, whatever the Node MCU is like an open source protocol. Okay, this is an open source IoT platform for connecting the sensors with the IoT. It includes some firmware which runs on the ESP8266 Wi-Fi SO. Okay. So this is the pin configuration of the Node MCU. In Node MCU we have only one analog pin and general input pins are 16 general purpose input output pins we have. And this MOSI, CS, MISO, S clock. These are the serial clock and serial data for master input and master output and slave input, master input and slave output. These are the SPI protocols. Parallel communication purpose we use this. So these are the specifications of the Node MCU, how much memory it supports, storage, and we connect the power with the using USB. So what is the software used in embedded systems? So for dealing with some Node MCUs and Arduinos, we use Arduino software like Arduino IDE. Okay. Whenever we use Raspberry Pi, all these operating systems, we write in code in a program Python language. In Arduinos and Node MCUs, we use embedded C. So Arduino IDE is one type of a software. It is a free open source software. This is the Arduino Sketch. So the code we write in the Arduino software is called as Sketch. We have some global variables, setup function and loop function. So global variables are nothing but we declare the variables at the top, like integers, float, whatever the variable we are using, we declare at the top. And setup functions, we initialize the setup functions like how many run once at the beginning. The pins, setting pins, what are the pins we are doing, connecting, some setup functions here. Loop is nothing but the repeating purpose, some automatically repeating purpose, running, like run repeatedly after some setup function, we write the loop format. So this int LED pin equal to 13. We are mentioning LED pin is connected to the 13th one of the Node MCU. And we int sensor not. So we connected to the 0 pin, D0 or A0. So state of the pin, like pin is low or high. So in setup function, we write the mode of the pin mode connections. We also write serial.begin, we give for baud rate. So this is a pin mode. So we connecting LED pin as output. We give LED as a output. So LED pin comma output. So we give some baud rate to that. Serial dot begin 9600. This is a constant baud rate for the computer to talk to the computer. How many bytes were transferred. So we loop function whatever based on the sensors we take, like analog signal or digital signal. Whatever we take, input or output. For output purpose we write like a digital write. For input we take an input digital one. So digital read, digital write. For working function we write digital write. Okay. Set a digital pin in high or low. Digital read like analog read or whatever the data we are collecting from the environment. So digital read or write. Read function we take for this input purpose. Okay. Analog read also same. If we connect to the analog pin, we write analog read. If we connect to the digital pin, we write as a digital read for input. So analog write is nothing but for DAC converters, digital to analog write functions. In pulse width modulation value, we analog write. Okay, delay is nothing but the amount of the time you have given in milliseconds, like 1000 milliseconds. So this Arduino UNO is a programming software language. We connect this with some Arduino like Atmega 328 Arduino UNO. So where you can upload the code to this Arduino board. You can use this link to download the Arduino IDE. Okay. After downloading, you can simply type in the Google also and download Arduino IDE. So after downloading, you'll get like this page. Okay. After clicking on it, we'll go to this page. Like you'll open the Arduino, you'll get this way. So you can see a tick button here, like tick, it's used to verify the code, and this one is to upload the data. So it's Arduino software used for verifying and uploading the data. Okay. So this is LED interfacing. So how we connect this LED to the breadboard? First we connect the D1. So in LED we have two pins now, analog pin and one data pin and ground pin. So ground pin we connect to the ground. LED we connect, we can give from D0 to D7. All these are the digital pins. So giving D1 to positive pin is given like cathode and anode. Ground is given to ground, and another pin is data pin is given to the D1. So sensors. A sensor is a device that collects some physical quantity and converts it into signal, which will read the data from the environment. So these are the examples of the sensors like water level sensor, LDR sensor, electricity sensor, analog sound sensors, current sensors. All these are the examples of sensors. You can know about some sensors like IR sensor. You can start our concept, like we already time is lacking. You can go for a topic. So these are the different sensors we use: fire sensor, pulse sensor, light dependent resistor. So you can go for today's topic is like IoT weather prediction. So how can IoT help for the weather predictions? Okay, application of IoT in weather. So first we use some DHT level sensor. So for going to the embedded system hardware, okay, we use a DHT level sensor for knowing the humidity and temperature. So weather predictions for knowing the weather quantity, like a DHT level suppose 0 to 50 degrees temperature. and you can get the accuracy of the humidity up to 80%. So the DHT11 sensor can use as analog. It has 3 pins: ground, power pin, and D0 or A0 pin. We can connect to analog pin or digital pin. So by using this DHT11 sensor, we connect it to the node MCU. So this is like just we can get the output. We can get some buzzer can take it as output. Whenever there is changes in the temperature, humidity, we'll get a buzzer alert. So this is just a hardware purpose. So how we include this this hardware with IoT? Okay. So we have different cloud platforms in IoT. So ThinkSpeak is one of the IoT application. Okay, this ThinkSpeak is an IoT analytic platform service for visualizing the and analyzing the live data streams in the cloud. You can see the live data like sensors we upload to the cloud. Now we can analyze the data in the cloud. We can like visualization purpose for data posted by the devices to the ThinkSpeak. I will tell you how to create a ThinkSpeak account. So this is a DHT11 sensor for weather predictions. DHT acts as temperature humidity to measure the values of temperature humidity. So ground pin to ground pin, and this data, this is to power. We give power supply, and one more pin to D5. You can give it to any pin. So it's connected to D5. So how we connect this IoT? First I will show you this account. So whenever you go to ThinkSpeak, you'll get a So in ThinkSpeak, first we have to same simple like any app you go, any website you go, how you register with your name, mobile number. Mobile number is not only name and email ID. You can register this ThinkSpeak. Okay. So in ThinkSpeak, after registering, you'll get this page like this. No, have to go to the option channels. So now I'm taking DHT11 sensor now, like a weather objection. So you can take this example channel ID 290. So we have to create a channel like this. You get your option channels. You have to click on a new channel, and you have to add the field one. Like field one, I've had a temperature. We'll get a graph like this in IoT. What is the temperature of the by temperature? What is the humidity? But with exact date and time, day and date, exact automatic by second, we will get the data. Okay. You can also analyze it in a MATLAB analysis. So this is a representation of the graphical view of the sensor's automatic monitoring. So in ThinkSpeak you'll have an API key. So when you go to the ThinkSpeak settings, you'll get an API key. So you'll put that API key in your code. So automatically the sensor data is uploaded to the cloud. Okay. Any doubts? So this is about the weather monitoring system, how we monitor the weather by using IoT. So we create some platform, ThinkSpeak platform. After registering in that, we'll create one channel. We will add the field one as a DHT level sensor as temperature and humidity. Now we create some channels. In that channel we create field 1 and field 2. After that we'll get that we have API read and API write key. We copy the API read key and we'll put it in the code, DHT1 code. Okay. So any doubts in this? These are the different types of gas sensors we use. This gas sensor is used for detecting any smoke or any poisonous gases like methane, butane. This is also a 4-terminal pin. Like we connect ground VCC, we have analog pin and digital pin. This is a MQ135 gas sensor. So we also use in some LPG concentrations. So MEMS sensor used for some position. Like it is a 360 degrees rotation, 60 degrees. Some fall angle rotation purpose, angle detection, we use this MEMS sensor for position tracking. So we also use some web page format for controlling the sensors. We use some HTML code and we write it in the web page, like a Wi-Fi based control. Okay, so all are related to IoT. So everyone, thanks for supporting me till now. So hope see you again. Bye. Thank you. Link share. Attendance link. Okay, I will share you the attendance link in the comments. Wait for 1 minute. So everyone please fill the attendance form and give me the feedback. Thank you. Yeah, then only you'll get the certificate for the attending the class.